Hello everybody, this week we're going to talk about our favorite little pogo stick spacecraft, OSIRIS-REx. OSIRIS-REx, or the Origins Spectral Interpretation Resource Identification Security Regolith Explorer, is a mission that's going to take samples in excess of 60 grams in size from an asteroid named Bennu and return it to Earth. If successful, this will be our most amount of matter returned from other bodies since the Apollo missions. This spacecraft includes many innovative and some old-school designs. First up, we have TAGSAM, the touch-and-go sample acquisition mechanism. TAGSAM grabs a sample by blowing compressed nitrogen gas onto the asteroid and then sucking it up into an air filter. This whole operation happens inside of about 5 seconds. Once TAGSAM has the sample, it then stores it in the sample return capsule, creatively named the SRC. The SRC uses a legacy design, which previously successfully returned a sample of Comet on the Stardust mission. One of the coolest parts of this instrument is its ability to bounce, which does make it, as we said, our favorite little pogo stick spacecraft. One of the other effects of the OSIRIS-REx mission is to make a model for the effects of heat on Bennu and how that alters its orbit. You see, Bennu is one of the near-Earth asteroids that's considered as a possible hazard asteroid. OSIRIS-REx will also be mapping the entirety of Bennu with lasers. The OSIRIS-REx Laser Altimeter, or OLA, is similar to radar but uses light instead of sound. It maps to the resolution of 1 point every 7 centimeters, and it comes with 2 settings. From about 7 kilometers to 1 kilometers in altitude, it uses the high energy setting, and from 1 kilometer and lower, it uses the low energy setting. Next up, we have a spectrometer named OSIRIS, or the OSIRIS-REx Visible Infrared Spectrometer. Spectrometers break down light into separate wavelengths, allowing us to see what things are composed of from far away. There's another spectrometer on board named REXIS, which is the Regolith X-ray Imaging Spectrometer, and this will be checking for exactly what Bennu is made of. It will be on the side that's always facing the asteroid. It has 4 X-ray sensitive CCDs, and this is built by students from MIT and Harvard. This is the most sensitive X-ray imager on any spacecraft. It's next generation, and it's completely built by students. Another one of the most notable things about the OSIRIS-REx spacecraft is its OCAMS instrument, which stands for the OSIRIS-REx Camera Suite. There are 3 different cameras. They're all visible wavelength. They're going to be taking different types of pictures, and we will definitely be seeing tons and tons of gorgeous pictures from OSIRIS-REx and the OCAMS instrument. I cannot wait. OSIRIS-REx also contains the HGA, which is the high gain antenna, and that is pretty self-explanatory. That allows us to contact the spacecraft, and that allows the spacecraft to beam back every little bit of wonderful information that it will gather for us. And lastly, we have the OSIRIS-REx Thermal Emission Spectrometer, or OTES. OTES is going to be measuring the Yarkovsky effect, and the Yarkovsky effect is a force exerted on a rotating body in space by thermal photons. Much in the same way a solar sail works, the massless photons still transfer momentum to the asteroid, and then that can actually influence its orbit. The Yarkovsky effect was discovered by Russian civil engineer Ivan Osipovich Yarkovsky in the late 1800s, who was working on the effects of thermal radiation on small objects in the solar system. Unfortunately, Yarkovsky was not known in his time, though for his contributions to science, he has gotten an asteroid named 35334 Yarkovsky. Launching on September 8th, OSIRIS-REx will enter the outbound cruise segment of its journey to Bennu, starting in October and then going on to August of 2018. It will last 712 days, and it will rendezvous with Bennu, where it will then conduct operations from the 17th of August 2018 to October of 2019. From then on, it will go into backup operations until 2021, before finally returning and dropping its payload in 2023. I cannot wait to see everything that's going to come out of this mission, and look forward to its launch. Thank you for listening to this episode of MicroCosmos. If you would like to support what we do here, make sure to head on over to patreon.com/Cosmocast, and don't forget to like and subscribe. Alright everybody, see you next week.